Assalamu alaikum and a very good day I bid to Dr. Nora and my fellow friends. Today, our group will discuss with you guys about the answers we got for the assignment task. We are from the group ENCEM, consists of 5 members, which are IDLAN, Firdaus, NALISHA, NURIN AIDA, and ZAMIR.
Heat pump and refrigerator utilize heat transfer from cold to hot. A. Draws the schematic diagram of a heat pump and refrigerator. First of all, you need to draw a circle like this. And then, write down the title of the diagram, which is refrigerator inside the circle. Next, draw a rectangle to write down low temperature reservoir, which is TL. For the upper of the circle, you just need to change the low temperature to the high temperature reservoir, which is TH. Next, write down QH and QL, and you just need to put it here and here. And don't forget to write W here. Draw one arrow toward the TH and 2 arrows towards the refrigerator. Meanwhile, for the schematic diagram of a heat pump, you just need to change the title in the circle, which is refrigerator to heat pump. So we are done the schematic diagram of a heat pump and refrigerator. Thank you.
B. Explain how the components of a heat pump and a refrigerator cause heat to transfer from a cold reservoir to a hot reservoir. The heat from a cold reservoir to a hot reservoir explains that the heat engine runs backwards. Based on this diagram, the heat transfer QC occurs to the working fluid in the evaporator from cold reservoir outside turned into a gas. The compressor increases the temperature as well as the pressure, then forced into the condenser coils. The heat from gas transferred to the room occurs the gas to condense to the liquid as the gas temperature is bigger than room temperature. The working fluid is cooled as it flows back from the expansion valve to the evaporator.
Okay, now we go to question C in part A. How is the coefficients of performance COP of heat pump and refrigerator are calculated? Now we need to know what is coefficients of performance COP. COP is coefficients of performance is defined by the ratio of heat dissipation and electrical power intake. It is the parameter by which the air conditioning unit's performance is evaluated. In refrigerator, we extract heat from cold region and maintain cold region to low temperature because the purpose of refrigerator is to cool the systems. Therefore, here we provide work by means of compressor. Low temperature reservoir, or we call cool region, we put here Q1, and high temperature reservoir, or we call hot region, we put as Q2. Here, the COP, that is coefficients of performance, is the ratio of heating effect or cooling effect to the work input. In refrigerator, cooling effect is Q1. We extract Q1 amount of heat from cold region and reject Q2 amount of heat to hot region. So difference of Q2 minus Q1 is work input, and here work input is compressor work. So therefore, COP for refrigerator is equal to cooling effect, that is Q1 over work input, which is Q2 minus Q1. Okay, now we go to heat pump. Heat pump is the device which transfers heat from low temperature to high temperature. Here, we take out heat from cold body, which is Q1, and deliver heat to the hot body. Deliver heat we call as Q2. Therefore, COP of heat pump is the amount of heat is rejected, or heating effect is Q2 over net work done, which is Q2 minus Q1. So therefore, COP for heat pump Q2 over Q2 minus Q1.
Okay, let's move to the part B. Ahmad bought a new refrigerator. To store the food, the temperature inside a refrigerator should be kept at 4 degrees Celsius at all times. Assuming that the temperature in the room is 25 degrees Celsius, determine the coefficient of performance. We know that the coefficient of performance of a refrigerator is heat removed by cold reservoir divided by work done by compressor. We can rewrite this as colder temperature divided by higher temperature minus colder temperature. So based on the question above, we know that the colder temperature is 4 degrees Celsius and the higher temperature is 25 degrees Celsius. So before we do our calculation, we must convert the degree Celsius unit into Kelvin. So 4 degrees Celsius is equal to 277 Kelvin and 25 degrees Celsius is equal to 298 Kelvin. So we just substitute the value we get from the question into the equation and we will get 13.19. Please remember that the value that we get indicates that the higher the COP, the higher the efficiency, thus the lower the energy consumption.
Part B, question 2. One day, Ahmed opened the refrigerator door to take some fruit and then he left the kitchen. After a while, he began to doubt whether or not he had properly closed the door. The question is, if the refrigerator door were left open, what will happen? The answer is, stated in the first law of thermodynamics, energy can neither be created nor destroyed. So the electrical energy, which is from electricity, is entering into the room in the form of work. And then it will extend the energy in the room. This increase in energy either can be stored in the system, which is in insulated room, or can be transferred the boundary in the form of heat in the open system or both. And since the room is insulated, the possibilities of heat interaction are zero. Thus, electrical work interaction will be observed as an increase in stored energy, and that is an increase in internal energy. And when the internal energy increase, it will be manifested by the rise in temperature. For the second question, is it possible to cool a kitchen by leaving the refrigerator door open? The answer is not possible. So let's take a look on the explanation of this answer. By looking at the first and second law of thermodynamics, it indicates that energy is never created nor destroyed. Instead, it can only be moved to another location or transformed into a different type of energy. This implies that to make something colder, you must remove heat in the form of energy by moving it or transforming it into other energy. And the key factor here is to make one thing colder, you must make something else warmer, which means the heat has to go somewhere. So if we want to make the kitchen colder, we have to remove the heat out of the kitchen. And in this case, let's say if we use the refrigerator to cool the kitchen, we vent the heat out of the refrigerator, usually at the back side of the refrigerator, but the heat is not out of the building or even the room. And the refrigerator system, the intent is to remove heat from the space inside the refrigerator, not from the room in general. So at the end, it will only increase the amount of heat inside the kitchen. Another implication of the laws of thermodynamics is that work is defined as a process that uses energy, where it is never 100% efficient. So there will always be some amount of energy that is used but does not contribute to the work's result. And normally, this energy escapes the system as heat. In addition, the energy being used to do the work is electricity, which is then transformed into mechanical energy in the motor that drives the pump that keeps the refrigerant moving through the cycle that moves the heat. Then, a small amount of that electrical energy becomes heat due to the friction in the motor, and that heat makes its way into the system's environment. So we can conclude that using refrigerator to cool the kitchen is not possible, and at the end it will only result to the rise in temperature inside the kitchen and makes it warmer.